So for this video, we're going to go over hashing. And so that's going to be one of our main things, but let's just touch on some of the smaller things that are involved before hashing on this review sheet. So the questions on the test will involve algorithms on sorting, searching, so that's linear and binary search, merging, and hashing. Just to go over really quickly, sorting algorithms are very important. We've got a couple of them listed here: selection sort, bubble sort, insertion sort, merge sort, and quick sort. So from the last test, we kind of already knew selection sort, bubble sort, and insertion sort. We move on to merge sort, and the clever thing about merge sort is that, first of all, it's a really good example for a recursive function. It also is it's just a cool sorting algorithm. The idea of merge sort is that if an individual element, so a list of just one element is always going to be sorted. And so you can break down a list into single elements and start merging them and making them sorted. And so that's a really cool concept. So that's something that you should probably look over. Quicksort, as far as I know, will not be on the test, but something that you can look over to better understand your recursive abilities and things like that. So that's sorting, and sorting is really helpful when we need searching. So searching can be done linear, and then there are binary searching. So we talked about this in the last exam, and so I'm not going to delve too deep into that, but I just want you guys to be aware that it will be there. Merging is also there. And now we can talk about hashing, and hashing actually solves a lot of the problems of sorting and searching. We can actually do a lot of things with hashing. And so I want to attract your attention again to the study guide. Here is where, let's scroll up. Sorry, scroll down. Hashing is where we're going to be, this is where we're going to be talking about hashing, and then we're going to talk about some of the problems. But the best place to learn about hashing is actually Geeks for Geeks, so I'm going to provide you with that link as well, and you can go and click and learn more about hashing right here. But I guess the really quick explanation of hashing is that, let's say that you've got this list, right? And in this list, you can put things as you go. So as you append, you could be putting like 11 there, 12 there. So this is what we want to put. We want to put this 11, 12, all that. We want to put those in like a list. And that can become very inefficient, because what if you don't know where 12 is, for example, right? This is ordered, but let's say that I put it in a list that's unordered, and you were looking for 12. It's difficult for you to find 12. And then let's say that you wanted to remove 12, right, from this middle of this list, then that would cause you to have to shift over 13 and 14 and 15, and that's way more than, it seems like it's a lot of work, actually. So hashing comes along, and hashing actually designates one of these, it designates a location for everything that can be hashed. So we have this thing called a hash function, which is right here. This thing over here, h of x is x modulo 10, and so we can use that to figure out where to put your numbers. And so I guess hashing is, you can think about it as, and I like this analogy. Hashing is like, imagine a parking lot, right? And in a parking lot, you can never find your car, or you can never find parking, right? So you can't find where to park, and you can't find your parked car after you go and do your things and you come back, right? You can't find it. So parking in certain places, right, you can have like reserved parking. And so that's the same idea of hashing, is that you're going to, everything that comes in, every car that comes into the parking lot will get a sort of reserved spot. And so you'll always know exactly where your car is, where you left it, and you'll also know where to park it. And it's really, really convenient for you, right? And so that's the whole idea, and it's a lot better than just going and finding your own parking spot. Now there is, again, overhead to that. You have to define a function that allows you to put the cars in the right spot, and sometimes that's not necessary, right? So that's why sometimes we just use a regular list, and other times we use a hash table or a hash set. And then there comes problems with, let's say that I have a really small parking lot with just, I guess, 5 or 6 different things, 6 different parking spots, and I have hundreds of cars piling in, right? Then what do we do? And so we can expand the parking lot, right? And that's really important. And so that, I guess, is akin to open addressing. That means that you can actually, if your parking spot's taken, then we'll give you another function that will tell you where to go, right? It'll give you like, okay, your parking spot, take that and add 5 to it. So 5 to the left, you'll get that next parking spot if it's open. just keep doing that. Now, let's say that this parking lot's very, very busy all the time, right? And so you're looking for parking spot one, but then they're like, okay, if it's full, let's move to parking spot number, move two parking spots over, so you end up at parking spot three, and you're like, okay, great, but parking spot three is also full, so I gotta keep moving, right? And at the end of the day, it starts to feel like you're doing the same looping around the parking lot looking for a spot to park, right? And we don't want to do that. We want to avoid that. And so that's where double hashing comes into play. So this is a link. Again, I'll post all of this, all the links there so you can follow along. But this says, okay, we can take one thing and we can hash it, we can hash another thing, and we can do multiple steps, and you can start to see that this avoids collisions. And collisions are what? Are basically two people trying to park at the same spot, two values wanting the same spot in that list. And so this idea is that hash one and hash two are hash functions, and you're going to be applying those two hash functions over and over again, and on this car or this item, right? And this will allow you to keep moving down the list. And that is the beauty of open addressing. And it's easier to implement than closed addressing, in my opinion. And it can be very efficient for large or medium-sized parking lots, air quotes, lists with small amount of data being put in, stuff like that. But then there comes a point when you just have too much. You can't keep circling around. It's inefficient. So we do something called separate chaining or closed addressing, in which you basically, and this may be a little bit where the analogy kind of falls apart, but you can make a parking lot on top of this spot in this parking lot. I like to think of them as like parking garages. So you can make like a parking garage at this spot, and then you can make another parking garage at this spot, just because so many cars are coming in and parking at these two different spots. And so then you can make those parking garages. And again, you can start to see that if you have a parking garage at that spot, like I can tell someone to go park at that parking garage, but then they still have to get inside the garage and go find the spot and go and park. And so then you can see that can become problematic as well. So separate chaining and open addressing, or closed addressing and open addressing, they can solve our problems, but you have to be careful with how they work. And sometimes the best way is to just rewrite your hash function to work a little bit better. But yeah, that's basically how I think about hashing, and that's pretty in depth on what's working. And we talked about, and you can actually tell I'm kind of I hate parking, hate searching for parking, right? But yeah, we covered a lot of this stuff. We talked about linear probing, which is the idea of that you just keep going. And so I did not mention, actually, let me cover that. I did not mention that, let's say that you were looking for, so we parked our car, right? Now we want to look for our car, right? We do our things, right? And then we come back and we were looking for our car. And so we use the same function to go and look for our car, right? But if our car isn't there, right? Let's say that I drive like a blue Toyota, right? If my blue Toyota is not there, then I know that's not my car. I'm going to go to my next spot, right? My next thing. Or I'm going to go to like the next thing over here or the thing over here. So that's like linear probing. You're like going spot by spot, right? And clicking your little clicker to get your car to beep or whatever so that you could go find it, right? So that's the idea there, right? And so that's linear probing. And then quadratic probing is just taking multiple steps at a time. You're like, okay, I'm going to just close my eyes. I'm going to walk past 4 cars because I know it's not in this range of 4 cars. I'm going to move past that, okay? What other things are there? Oh my God, you're seeing preview. That's quadratic probing, linear probing, and double hashing is actually moving at multiple different ways. So it's not linear. So like, let's say that you have a huge parking garage. You don't want to move like car by car or every 4 cars or every 10 cars. You might want to just like move garage by garage, or sorry, floor by floor in the parking garage, right? And that could be really, really helpful as well. And so with double hashing, you can get that as well. The next thing that I do want to mention for, I guess, just how these open and closed addressings, they both work. And one thing I want to reiterate and one thing I want to emphasize is that your function may not be working correctly if everything is hashing to one spot. You might have to look at your function again, or you want to look at how this insert works. And so that's the whole idea. And so I highly recommend that you, if you don't understand this, give this a read, and there's more stuff that you can look at. There's more things over here, some problems on how this stuff works. It's a very, very common data structure. In fact, Python's dictionary and Python's set data structures are hash tables at the end of the day. And so this is something that you can look at and you can definitely learn from. And this is something that will be on the test for sure. And so you can head over here and you can go into this and you can look at exactly what's going on. But besides that, I think that covers all of the hashing stuff. Um, some of the assignments that we covered, for example, let me go find the assignments. Some of the assignments that we covered, which was assignment, I believe the reducibles, which is assignment 12, required a lot of hashing. And you can see over here, this is your hash word, this is your figuring out the prime, and then you have your steps as insert, find, and is reducible. These are some functions that you should rewrite or look at and see what's happening. And then is reducible was actually a recursive backtracking problem. And so you, using the last video and using this video, you can kind of work on this and then you'll be very, very good with both of the concepts. All right. That's basically it for me on hashing and where'd it go? Hashing, sorting, searching, and merging. Okay, if you have any questions, definitely ask on Piazza. Okay, I'll see you in the next video.